Hey there guys, welcome to my walkthrough of the November 2017 Edexcel Foundation GCSE Maths Paper 3. It's a calculator paper. Make sure you check out the description for lots of useful content, including the paper itself, my playlist with every past paper walkthrough in it, formula video, calculator tricks, and topics to help with this paper. Let's go. Okay, number one says to write 3,758, correct to the nearest 1,000. So, hopefully you can see it's closer to 4,000 than 3,000. That is our guy. Question 2 says to simplify y, add 3y minus 2y. Okay, so y add 3y gives us 4y, so we have 4y minus 2y, which is 2y. Okay, number 3 says to write down all the factors of 18. So, factors are the numbers that divide 18 exactly. Best way to do this is in factor pairs. So we have 1 and 18. 2 and 9. And 3 and 6. Okay, number 4, the table shows information about the prices of cinema tickets. So an adult costs $7.80, child costs $5.80, and a family ticket, which is for 4 people, costs £24.30p. Mr. Edwards and his 3 children go to the cinema. It is cheaper for Mr. Edwards to buy a family ticket rather than 4 separate tickets per day. How much cheaper? Okay, so we need to work out how much it would cost to buy 1 adult and 3 child, and then subtract the cost of a family ticket from that. So, 1 adult costs £7.80. 3 children would be 3 times £5.80. Now remember, it's a calculator paper, so you can do it on that. So that's going to be £17.40p. Now, altogether then, that is going to be, if we add them together, that is going to give us £25.20p. So then, to work out how much cheaper it is to buy a family ticket, we then do 25.20 minus 24.30, and that gives us 90p. Okay, then for part B, we are told that the film starts at 6:45 p.m. The film lasts 102 minutes. What time does the film finish? Okay, so first thing I would do is convert 102 minutes into hours and minutes. So 1 hour is 60 minutes. So 102 minutes is 1 hour 42 minutes. Now 6:45 p.m. and 1 hour is 7:45 p.m. Now we have 42 more minutes to add on. So if we add on 15 minutes, that's going to get us to 8 p.m. Now 42 minus 15 is 27. So we have 27 more minutes to add on. That's going to get us to 8:27 p.m. Okay, number 5. This maybe has a large bottle of shampoo. There are 2 litres of shampoo in the large bottle. This also has some empty small bottles. Each small bottle can be completely filled with 150 millilitres of shampoo. We want to work out how many small bottles can be completely filled with the shampoo from the large bottle. Okay, so what we need to do here is first of all turn 2 litres into millilitres. So 1 litre is 1,000 ml, so 2 litres is 2,000 millilitres. Now what we need to know then is how many whole lots of 150 are in 2,000. So we do 2,000 divided by 150, and that gives us 13.3 recurring. Now that means then 13 bottles can be filled completely. Okay, and for number 6, we are told that the incomplete pictogram shows info about the number of cycles sold in a shop on Tuesday, on Wednesday, and on Thursday. Okay, so we have nothing in the key, so we are told a total of 20 cycles are sold on Tuesday, Wednesday, and Thursday. 8 cycles are sold on Friday. 15 cycles are sold on Saturday. We want to use this info to complete the pictogram. Okay, so we know that a total of 20 cycles are sold on Tuesday, Wednesday, and Thursday. So what that's going to allow us to do then is work out the key, and then we can fill in the other 2 dates. So together here we have 4 whole wheels and 2 halves. So together, that's 5 whole wheels. So we know then that 5 wheels equal 20. So 1 wheel represents 4. So we need to put that in the key. Okay, so now that we know the key, we can fill in the other 2 days. So we were told 8 cycles were sold on Friday, so we need 2 wheels. And we're told that 15 cycles are sold on Saturday. So 15 cycles is going to be 3 wheels, which would be 12, and then 3/4 of a wheel to give us 3 more. So we're going to need that would be 12. And there is our 15. So that is our completed pictogram. Okay, number 8, we have some scale drawing fun. So here then, the picture shows a bus next to a building. The bus has a length of 12 meters. And the bus and the building are drawn to the same scale. We want to work out an estimate for the height in meters of the building. Okay, so if you have this printed off properly to scale, what you need to do is measure the length of the bus. So you should get that is about 2 centimeters. Now that tells us then that 2 centimeters represents 12 meters. 1 centimeter represents 6 meters. And then if you measure the height of the building, you should get about 5 centimeters. So then you do 5 times 6 meters is 30 meters. Okay, number 9. Nida maybe writes down 2 different prime numbers. She adds together her 2 prime numbers, and her answer is a square number less than 30. We want to find 2 prime numbers that Nida could have written down. Okay, so our square numbers less than 30 are 1, 4, 9, 16 and 25. Now, if we write down our primes, so we can't write them all down because they go on forever, but clearly we're not going to need any bigger than 30. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Now, what we need to do is find any two of these that add together to give us one of those square numbers. So for example, we could have 2 add 7 is 9. We could have 5 add 11 is 16. We could have 2 add 23 is 25. So we only need one pair, that'll do. Okay, number 10. We are told Jim thinks of a number. 2/3 of Jim's number is 48. Work out 5/6 of Jim's number. Okay, so we know that 2/3 is equal to 48. What we need to work out first of all is what 3/3 is, so the whole number. So we can work out what 1/3 is by dividing by 2. So 1/3 is equal to 24. So Jim's number is 3 times 24, which is 72. Okay, then we want to work out 5/6 of that. So you can do this on your calculator. Just put in the fraction times 72. I'm going to do it now because it's good practice. So 1/6 of 72 is 72 divided by 6, which is 12. So then 5/6 is 5 times 12, which is 60. Okay, number 11, we have some Best Buy. So Jack's driving school has 2 offers. Offer 1 is the first driving lesson is free. All others are the normal price. Or offer 2, all driving lessons 5% off the normal price. The normal price of a driving lesson is £24. Douglas is going to have 12 driving lessons. What is the cheaper offer for 12 driving lessons? Offer 1 or 2. You must show your working. Okay, so by offer 1, he's going to need to pay for 11 lessons at the normal price. So that's 11 times 24, which is £264. Now for offer 2, so if you get 5% off the cost of every lesson, you can work out the total cost of it normally and then take 5% of that off at the end. If you prefer, you could reduce the price now by 5%. So normally then 12 lessons would be 12 times 24, which would be £288. Now we need to take 5% off of that, so lots of ways you can do this. You could find 5% of it and then subtract it. The really clever way to do it is to use your calculator and do 0.95 times 288. That's finding 95% of 288. And that gives us £273.60p. So, offer 1 is cheaper. Okay, number 12. We are told 2.5 kilograms of apples cost £3.60. Work out the cost of 3.5 kilograms of apples. Okay, so something that's very useful to spot here is that 0.5 kilograms goes into both 2.5 and 3.5. So if we find the cost of 0.5 kilograms, which we can do by dividing by 5, we get 0.5 kilograms is 72p, 0.72, and then this is like 5 times tables, so we want 0.5s into 35s, 3.5s, which is the same as 5 into 35. So we now multiply by 7, and we get 3.5 kilograms is 7 times 72p, which is £5 and 4p. Alright, number 13, we want to, for part A, complete the table of values for y equals 1/2 x minus 1. So that means, to find the value of y, we halve whatever x is and subtract 1. So, when x is minus 1, y is 1/2 times minus 1, which is minus 0.5 minus 1, and that gives us minus 1.5. Okay, then when x is 0, we get y is 1/2 times 0, which is 0, minus 1, which is minus 1. When x is 1, y is 1/2 times 1, so 0.5. Minus 1, which is minus 0.5. Now, if we look at the numbers as a pattern, we are adding 0.5 every time. So the last one will be 0.5. Of course, you can check it using the equation. Okay, then part B. On the grid, draw the graph of y equals half x minus 1 for values of x from -2 to 3. Okay. So what we now want to do is plot these points. So remember, x is our across, y is our up and down. So the first point to plot then is -2, -2. So that is there. Then we're going to have -1, -1.5. So that's there. The next one is 0, -1. Next is 1 minus 0.5. Next was 2, 0. And then the last one was 3, 0.5. Okay, and then you want to join those points. Using a ruler with a straight line. So this might not go very well, but we'll try. Cool. So your line should look like that. Okay, then part C, which I totally didn't miss, wants us to use the graph to find the value of x when y equals 0.3. So what that means is find where y is equal to 0.3. So the scale is 1 big square represents 1. So every little square is 0.1. So y being 0.3 is there. So we now go across until we hit the line, which is there, and then go down to the x-axis to get the value. So that's gonna be 2.6. Okay, number 14 wants us to describe fully the single transformation that maps shape A onto shape B. Okay, so hopefully you can see the shape has flipped. It's symmetrical about the x-axis, so it's a reflection through the x-axis. Okay, number 15. The ratio of the cost of 1 meter of cotton fabric to the cost of 1 meter of silk fabric is 2 to 5. We want to complete the table of costs. Okay, so first of all, I'm going to write down the ratio C to S is 2 to 5. Now let's have a look in the table. Okay, so we can see that for cotton, 2 meters costs £6. So, for cotton, £2 costs £6. Now that means that 1 meter costs £3. So, what that allows us to do is fill in all of the costs for cotton. So, 6 meters is going to cost £18. 6 times 3, 8 is going to be 24. And 9 will be 27. Now, what we need to do is work out how much 1 meter of silk would cost. So again, if we play around with the ratio, so we know cotton to silk is 2 to 5. Now that's for 1 meter. So that's saying for every £2 that cotton costs, the silk would cost £5. So let's turn 2 into £3, or just into 3. So 3 divided by 2 is 1.5. So to do that, we've multiplied by 1.5, so we're going to do the same to the silk. And that is going to give us 7.5. Now that tells us then that the silk costs £7.50 per metre. So for 2 metres, it's going to be £15. 6 metres, 6 times 7.5, it's 45. 8 metres is going to be £60. And 9 metres is going to be £67.50. Okay, number 16. Chloe has a van. She's going to use the van to deliver boxes. Each box is a cuboid, 40 centimetres by 30 by 35, as shown. We are told the space for boxes in the van has a maximum length of 2.4 metres, maximum width 1.5 metres, maximum height 1.4 metres. The space for boxes is empty. Chloe wants to put as many boxes as possible into the van. She can put 3 boxes into the van in 1 minute. Assume that the space for boxes is in the shape of a cuboid. Part A, work out how many minutes it should take Chloe to put as many boxes as possible into the van. Okay, so what we need to work out then is how many boxes she can put along the length along the width and along the height of the space in the van. So, what we're going to do, first of all, because the measurements of the boxes are in centimetres, we're going to convert the space in the van into centimetres too. So it's 10 metres into centimetres multiplied by 100. So the length is 240, and the width is 150, and the height is 140. So, along the length, so she can get 240 centimetres divided by 40 centimetres along the length, which is 6. And then 150 divided by 30 along the width, which is 5. So imagine she's putting these in layers. We now know the layer is going to be a rectangle with 6 times 5 boxes. Now we need to know how many layers she can get in. So we're going to do the available height divided by the height of a box. So 140 divided by 35 gives us 4. So that's 4, what should we call it? She can get 4 layers. So the number of boxes where she can get into her van is 6 times 5 times 4, which is 120. Now the fun isn't done. We are told that she can put 3 boxes into the van each minute. We want to know how many minutes it's going to take. So we now need to do 120 divided by 3, which is 40 minutes. Okay then, for part B we're told the space for boxes may not be in the shape of a cuboid. How might this affect the time it takes Chloe to fill the van? So, if the available space has a bigger volume than the cuboid, she might be able to get more boxes in, which will take more time, or if it has a smaller volume, she'll be able to get less boxes in, which would take less time. Okay, 17a wants us to factorise 4m add 12. So, factorise means to put back into brackets. So the common factor here is 4. Now 4m divided by 4 is just m. And then 12 divided by 4 is 3. Okay, then for part B, we want to choose 2 words from the box above to make this statement correct. So 5y is a something in the something 3x add 5y. So the words we have then are expression. We want that straight away. So 3x add 5y is an expression. So that's gonna go there. And then the first word we want is term. So 5y is a term in the expression 3x add 5y. Okay, number 18 we have sequences, so my playlist is down below. So, we are given a sequence of patterns made with counters. Find an expression in terms of n for the number of counters in pattern number n. Okay, so nth term. So the first thing we need to know is how many counters are in each pattern. So in the first one, we have 4. In the second, we have 7. And in the third one, we have 10. So, the first step to finding nth terms is to find the difference. So we're adding 3 each time. So that means the sequence is something to do with 3n. Now, n is just the term number. So we know the first term is 4. For the first term, n is equal to 1. So if we substitute that in, we get 3 times 1 is 3. And then we need to either add or subtract something to get up to 4. So as it goes, we're going to need to add 1. Now we can always check this. When n is 2, we should get 7. So 3 times 2 is 6, and 1 is 7. When n is 3, we should get 10. 3 times 3 is 9, and 1 is 10. B. Okay, then for part B, we are told Bayo has 90 counters. Can Bayo make a pattern in this sequence using all of his counters? We must show how we get our answer. So, we don't want to keep writing down terms in this sequence until we either get to 90 or past 90. What we do is we set the nth term equal to 90 and solve for n. Now, if we get a whole number, that tells us the term number that would use 90 counters. If we don't get a whole number, that means we can't make a pattern in this sequence using 90. So, if we set 3n and 1 equal to 90, subtract 1, 3n equals 89, and then if we try to divide by 3, we would get n is 29.6 recurring, which isn't a whole number, so no. He cannot. If we just got 29 on its own with no decimals, that would mean the 29th term would use 90 counters. But you can't have term number 29.6 recurring. Makes no sense. Number 19, the table shows information about the heights of 80 children. Our job is to, first of all, find the class interval that contains the median. Okay, so we can't find the actual median value because the data is in groups. So, what we need to do, the median is the middle. So what we need to do is divide the number of people by 2. So 80 divided by 2 is 40. Now because there is an even number of people, there isn't actually one person in the middle. The median value would be halfway between the 40th and 41st person, but we don't really care about that. All that we need to do is go through the frequencies and add them up until we get the interval containing the 40th and 41st person. So, if we go in from the top, we have 4, add 11, it's 15, add 24 is 39, add 22 is 61. So, the 40th and 41st person are in this interval 160 less than or equal to h is less than 170. Okay, then part B wants us to draw a frequency polygon for this info. So, spoilers, that's a frequency polygon. Now the important thing is that you use the midpoint of each interval as the x coordinate. So the first point would be 135 and then 4 up. So do that for all of them. Now you join the points together with straight lines. Don't join the two end points together and don't connect to the axes. Okay, number 20, unit conversion. So in London, 1 litre of petrol costs 108.9p. In New York, 1 US gallon of petrol costs $2.83. 1 US gallon is 3.785 litres, and £1 is $1.46. In which city is petrol better value for money, London or New York? And you must show your working. Okay, so all we need to do is either turn the cost in, or the values in London into a US gallon and dollars, or the values in New York into 1 litre and pounds. So I'm going to turn the values in London into a US gallon and dollars. So in London, one litre costs 108.9p. Now that is 1.089 pounds. Okay, so now what I'm going to do is turn 1 litre into a US gallon. So I'm going to multiply both sides by 3.785. So 3.785 litres is going to cost, now we need to do 1.089 times 3.785, and that gives us 4.121865. So that's pounds. Really, we'd be fine just going 4.122. So that then tells us that 1 US gallon costs 4.122 pounds, or 412.2p. Now what we need to do is turn that into pounds. So we know we want to turn that into dollars. So we know every £1 is $1.46. So we're going to do 4.122 times 1.46. Now that gives us $6.02. So that's the cost of 1 US gallon in London. In New York, it cost $2.83. So New York is cheaper. Okay, number 21. A gold bar has a mass of 12.5 kilograms. The density of gold is 19.3 grams per centimetre cubed. Work out the volume of the gold bar. Give your answer correct to 3 sig figs. Okay, so if you don't know the formula for density, it is given to you right there. Grams is a measure of mass, centimetre cubed is a measure of volume. So density is equal to mass divided by volume. Now what we're trying to find is the volume. So if we multiply through by V, we get V times D is equal to mass. And then if we divide through by density, we get volume is mass over density. Now we need to be careful because we have a mix of units. The mass is in kilograms, the density is in grams. So we need to turn 12.5 kilograms into grams. So, to do that, we multiply by 1,000. So 12.5 kilograms is 12,500 grams. So the volume is 12,500 grams divided by 19.3 grams per centimetre cubed. Now stick that into your calculator and we get 647.6 blah 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 blah. The third significant figure is the 7, which has a 6 after it, so that rounds up to 648 centimeters cubed. 22 some ratio fun, so there are only blue pens, green pens and red pens in a box. The ratio of blue pens to green pens is 2 to 5. Straight away I'm writing that down. Blue to green is 2 to 5. And the ratio of a number of green to a red is 4 to 1. Okay, then we're told there are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Okay, so what we're going to need to do is combine these two ratios into a single ratio. Now I do have a video on this with more examples which will be down below. So the trick to doing this is the part that comes up in both ratios. So here, that's green pens. Now what we need to do is turn that part of each ratio into the same number. So, the first thing that 5 and 4 both go into is 20. So the ratio on the left is going to be multiplied by 4. So that's now going to be 8 to 20. And on the right, we need to multiply it by 5. So that's going to be 20 to 5. So, what this now tells us is for every 20 green pens, there are 8 blue and 5 red. So, as a single ratio, blue to green to red, we have 8 to 20 to 5. Now, imagine that we had loads of these pens to put in a box. This means that in one go, we need to put in 8 blue, 20 green and 5 red. So, altogether, we are putting in 33 pens at a time. Now we are told there are less than 100 pens in the box. So we now need to work out how many lots of this ratio could we put in the box. So if we do 100 divided by 33, we get 3.3 recurring. Now that means then that we can put 3 lots of this ratio into the box, which means we can put in 3 times 5 red pens. And 3 times 5 is 15. So there could be 5 red pens, 10 red pens, or 15 red pens. 15 is the answer because we wanted the greatest possible number of red. 23 wants us to find the value of the reciprocal of 1.6, giving our answer as a decimal. So all that reciprocal means is 1 over the number. So the reciprocal of 1.6 is 1 over 1.6. Stick that in your calculator and you will get 0.625. Okay, then part B says that just round a number x to 1 decimal place. The result is 9.8. Write down the error interval for x. Okay, so again, error intervals are down below. Basically what this means is we need a double inequality with x in the middle, and we want the lower bound and the upper bound of what x could be to then round to 9.8 to 1 decimal place. So for the lower bound, you always use an or equal to inequality, and we want the smallest number that would round up to 9.8. So that would be 9.75. And then for the upper bound, you use a strict inequality. And then we want the first number that wouldn't round down to 9.8. So that's 9.85. Okay, number 24. So we're given a rectangle and we are told the length of the rectangle is 7 centimeters longer than the width. So before we go any further, let's think about what that means. We don't know the value of either. So what do we like to call things in maths when we don't know their value? Other than a pain in the arse, we call them x. So if we call the width x and the length is 7 longer, that means the length is x add 7. Okay, back to the story. So we're then told 4 of these rectangles are used to make this 8-sided shape. The perimeter of the 8-sided shape is 70 centimeters. We want to work out the area. Okay, so it's 5 marks, and what this is forming and solving equations. So, given that we know what the perimeter of this shape is as a number, we can also find it in terms of x, which is going to allow us to form an equation in terms of x, solve for x, and then do what we need to do. So let's go around labeling lengths. So we have x there, we have x there, we have x at 7 there, we have x at 7 there. What about the top and bottom? Well, we have x there and x at 7 there altogether. That's 2x add 7 and then the other two lengths that we need are this bit and this bit. Now we know altogether this whole length is x add 7. We know this bit is x, so this bit must be 7. So then it's the same there. Okay, so now that we know all the side lengths, we can work out the perimeter in terms of x. So let's count up all the x's first of all. So 1, 2, 4, 5, 6, 8. So we have 8x. And then we have 7, 14, 21, 28, 35, 42. So the perimeter in terms of x is 8x and 42. Now we also know the perimeter is 70. So we can set this equal to 70. Now we want to solve this for x. So subtract 42 and we get 8x is 28. And then divide by 8 and we get x is 3.5. So now that we know what x is, we can work out the area of one rectangle. So one rectangle is now 3.5 centimeters by 10.5 centimeters. So the area is 3.5 times 10.5 centimeters, and that is going to give us a number that's going to give us 36.75 centimeters squared. Now remember, we want the area of the 8-sided shape, so it's made from 4 rectangles, so the total area is 4 times 36.75 centimeters squared, which gives us 147 centimeters squared. Okay, number 25 wants us to work out 13.8 times 10 to the 7 times 5.4 times 10 to the minus 12, giving our answer as an ordinary number. So work it in your calculator exactly how it stands then you should get 7.452 times 10 to the minus 4. So that's in standard form. Now what that means is if we have 7.452 times 10 to the minus 4, that means the decimal point needs to move 4 places to the left. So it's going to go 1, 2, 3, 4. So everywhere behind the 7, where there's a little round bit, you're going to need a 0. So it's going to be 0.000745 Number 26. When a drawing pin is dropped, it can land point down or point up. Lucy, Mel and Tom each dropped the drawing pin a number of times. The table shows the number of times the pin landed up or down for each person. We're told Rachel is going to drop the drawing pin once, whose results will give the best estimate for the probability that the drawing pin will land point up. Give a reason for your answer. Okay, so when you carry out a trial, so here dropping a drawing pin, you can get what's called the relative frequency of a certain outcome. That's the number of times that outcome happens out of the total number of times you do the trial. And then you can use relative frequency to estimate the probability. So whatever the relative frequency is, you take that as the probability. So in short, the more times you carry out a trial, the more accurate your results are. So we are looking for the person that dropped the pin the greatest number of times. So Lucy is 45, Mel is 80, and Tom is 25. So our answer is Mel, and I'm not going to write the reason, but it's because she dropped the drawing pin the most times. Okay, then for part B, Stuart is going to drop the drawing pin twice. We want to use all the results in the table to work out an estimate for the probability that the drawing pin will land point up first time, point down the second. Okay, so when it says use all the results, what we're going to do is work out the total number of times they all dropped the pin. So let's do that first. So 45 add 80 add 25 is 150. Now we can work out the probability of it landing down by adding up all the times it landed point down. So 31 add 53 is 84, add 16 is 100, and that means the number of times it landed point up has to be 50. So the probability of a landing point down is 100 out of 150, which is 2/3. So then the probability of a landing up will be 1/3. Now we want the pin to land up the first time, down the second. So we can say the probability of up, down. Now all that we do is multiply the probabilities together. So it's 1/3 times 2/3, which is 2 notes. Number 27, final question, simultaneous equations. If you're rusty, playlist down below. So we want to solve x add 3y equals 12 and 5x minus y is equal to 4. That means we need to find the value of x and the value of y. So the very first thing to do is to call them 1 and 2. Now what we need to do is get one equation in terms of just one letter. To do that, we need two equations with the same amount of the same letter, so we can then get rid of it. So we can go for either x or y. I'm going to go for, let's go for the y's. So even though we have a positive y term and a negative y term, as long as they still have the same number attached, we can cancel them out by adding the equations together. So I'm going to turn minus y into minus 3y. I'm going to do that by multiplying equation 2 by 3. So that's going to give me 15x minus 3y is equal to 12. Now we're going to call this equation 3. Now to cancel out y and minus 3y, we're going to add them together. 3y add minus 3y is 0. So now we're going to do 1 add 3. So we've now got x add 15x, which is 16x. 3y add minus 3y is nothing. And 12 add 12 is 24. Now to get x, divide by 16. So we get x is 24/16. Which is 3/2, which is 1.5. So we now know x is 1.5. Now to find y, we put the value of x into either equation. So I'm going to put it into equation 1. So we then know that 1.5 add 3y equals 12. Take away the 1.5 and we get 3y equals 10.5. Divide by 3 and we get y is 3.5. So, there guys, is the paper done. Hope you found it useful. Don't forget you can get to every paper in one playlist down below. Don't forget to subscribe, give us a thumbs up, drop us a comment with any requests down below. Take it easy, take care.